All right, before we start for number 2, I just want to write down off on the side what our 3 options are for trig substitution. So you're going to pick one of these 3 things. We're going to pick either x is some number sine theta. We're going to pick that x is some number tan theta. We're going to pick that x is some number secant theta. Now, as you're doing these, worst case scenario, you have no idea which one to pick. You pick one, it doesn't work. You pick another, it doesn't work. You pick the third one, it works. That's worst case. You'll get better at picking which one is which as we go. But 2 of them will not work. And then the other one is the one that's going to give us what we want. So let's do number 2 together. Number 2, again, you do want to go through and think about, can I do this any other way? Because there will be ones that you can, especially if that was an x, not an x cubed. I can't figure out how to maneuver this one so that it matches up because it's an x cubed. No idea how to do partial fractions when I have a square root on the bottom. And so it must be trig substitution. So this one, again, I'm going to choose sine. So I'm going to let x be equal to, this time I want 3 sine theta. That means that dx is going to be 3 cos theta d theta. And I'm going to plug this all in for my x and my dx. And it's going to be a little bit messy, but that's okay. Up on the top, I'm just going to go ahead and cube x right away. So that's going to be 27 sine cubed. And then I think I'll just throw dx on top as well. So that's going to be 3 cos theta d theta. And then on the bottom, I have my square root of 9 minus, and I'll square it right away. So I have this. Now I want to clean things up a little bit. Of course, on the bottom, I'm going to have a 3. That's going to pull out of my square root. Whoops, that's a times. And then I'm going to have a 1 minus sine squared, which is cosine squared. And then I'll take the square root of it, so I'll just write it as cosine. All right. Luckily, cancel, 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 because I picked right, frankly. And now I can do out this integral. I'm going to pull my 27 out in front, and I'll do the integral of sine cubed. Oh, hey, we've done this one before. The trick to this one is rewriting sine as sine times sine squared. So that's going to be 27 sine of theta, and then I'm going to change sine squared into 1 minus cosine squared. Distribute. That's going to be sine theta minus sine cosine squared. And then I can take the integral of each of those pieces. So I have 27 on the outside. Sine came from negative cosine. Over on the second term here, I have the spawn of the chain rule. So that's going to be cosine cubed over 3. And let's see, when I chain, the negative is going to show up. So I'll put a plus. And I could put the plus c now, or I could do it at the end. I'm just going to wait till the very end because we don't have x's, but also we can't just do a direct substitution like we did last time. We have to take this and we need to go and draw ourselves a triangle. We're going to draw ourselves a quadrant 1 triangle, always quadrant 1. And I'm going to put my angle in here. And if x over 3 is equal to sine, then I'm going to end up with an x here and a 3 here. I can do the Pythagorean theorem so that on the bottom, I get the square root of 9 minus x squared. And this should always be familiar because that was in our original problem. So that's kind of a self-check that you can do to make sure that you have it all set. All right, now looking at this triangle, what do I need? I just need to know what cosine is. So from the triangle here, the cosine of my angle is going to be root 9 minus x squared all over 3. And now I can use that to plug in and get my final answer. All right, so let's see. My final answer, I think I'll go ahead and distribute the 27 as I plug in. So I'm going to have 27 times negative cosine, which is going to be root 9 minus x squared over 3. And then I'm going to have plus cosine cubed over 3. So I'll put the 1/3 out in front. Cosine cubed is going to have a 1 over 27. And then I'm going to have, oh, I don't love this. I don't really want to have my radical cubed. So I think I'll just change my notation to be 9 minus x squared to the 3/2. And then I forgot to distribute the 27, so I have another 27 in there as well. All right, clean this up a little bit. My 3 and my 27 are going to cancel. My 27 and 27 are going to cancel. So I get negative 9 root 9 minus x squared plus 1/3 times 9 minus x squared, all to the 3/2. And now finally here, I'll throw on my plus c. Never would I have guessed this as the answer to number 2. It's pretty messy. I can kind of see the relationship to some sort of sine, hopefully, right? Like it kind of reminds you of arc sine a little bit, which can help you get that original x value. But notice no arc sines show up in your answer. Actually, I'm going to suggest that you try number 3. I'll put a screenshot of the answer in Google Classroom, and then if you want to see number 3 done out, I will do it out, but you don't have to watch that one if you feel good. Pause now if you want to try it completely on your own, but I will give you a hint for number 3 that you should choose your x to be 7/2 secant theta. And I'll do that one in a separate video. Whoops. Sorry.